for all these lectures. Okay. It's not sharing.
Detector speaker. We make sure the speaker is on.
Okay. Also, can you guys respond if you can see my notebook?
Yes, sir.
Yes,
Okay.
sir. Yes, sir.
Okay. So let's start. Good morning, everyone, and welcome to this physics class at RGIPT. And I think you guys already had one class on chemistry from Dr. Singh, right? So we'll start this physics class, and this is mandatory for all of you. And in this batch, I think you guys are from math and computing and electronics engineering and e-vehicles. And so regarding some of this class logistics, why I can't see. Just 1 minute.
ఫోన్ ఆయన వచ్చాడా సరే.
Okay, so this course is called classical physics, and this is your course code is PY101. So this course is basically called classical physics, and your course code is PY111. And in the next semester, you will have another physics course that is called modern physics. So you will have to read physics for 1 year for the whole first year of your BTech undergraduate course. And in this classical physics, let's start with the schedule. So for your batch, you have classes every day, I think, and every day at 10 a.m. So your classes will be on Monday, Tuesday, Wednesday, and Friday. And these 4 days at 10 a.m. And you also have one tutorial class. One tutorial class that is on Thursday. I think all of you have the class schedule. So this Thursday tutorial, this will be at 2 p.m. Okay. So in this regular lecture, Monday, Tuesday, Wednesday, and Friday, we'll basically discuss the theoretical and various numerical aspects. And on Thursday, basically what we'll do that if you have any doubts regarding your tutorials or assignments, so you can ask me on those tutorial, or if you have any tutors assigned on that day, you can ask them to clarify your doubts. So this is basically your class schedule. And also regarding this Zoom link, so every day we'll meet on the same link. Okay, I think this link should work for at least 1 month. So we'll meet on this link every day at 10 a.m. and Thursday at 2 a.m. on the same link. If this link does not work, so then you can let me know by email that this link is not working, then I'll create another link. But hopefully this link should work for at least 1 month. So okay, so yeah, so we'll meet every day on the same link. Okay. And regarding your grade structure for this course, so you have total 10 credits for point for this course, and the weightage is divided is something like that. You have mid-sem that carries 30% weightage, and your end sem that carries 60% of your weightage, and your assignment plus quiz, this carries 10% of the marks. Okay. And regarding assignment, so you will have assignment every week, and you have to submit the assignment by Friday of that week. So assignment deadline is Friday, and I will not accept anything after this Friday. Okay. So every week, hopefully by Saturday, I'll give you the assignment. Except this week, I think this week you will not have enough material for any assignment or tutorial. So from next week onwards, I'll give you assignment by Saturday, and you have to submit the assignment by Friday every week. And so you will get about 12 to 14 assignment for this whole class during this entire course. Okay. And regarding quiz, I'll take 3 quiz. Okay. During this course, we will have 3 quizzes, and I'll take best 2 out of 3. Okay. Best 2 quizzes out of this 3. I'll count marks. Okay. So this is your grade structure. That mid-sem carries 30% weightage, end-sem that carries 60%, and assignment and quiz that carries 10%. And we'll have 3 quiz, and I'll count best 2 of 3. So even if you miss some quiz, or then you can do better on the next one. Or if you try to improve, you can take all the 3 quizzes and try to improve. Okay. And regarding course, this course is basically called classical physics. And there is 4 unit. In this course. So unit one is basically we'll start something on the vector calculus and coordinate system. This part is called classical mechanics. This part is called classical mechanics. Here we'll read vector, coordinates, and mechanics. And these are the units. So unit 2 will read some statistical mechanics and some black body radiation. So we'll read distribution formulas. Distribution, statistics, and radiation. Something like black body radiation. And this unit 1 and unit 2, hopefully these 2 will be the course material for your mid-sem. and mid-sem most likely will take place after you come to this campus in the September or end of September or October. I'm not sure at this point, but something around that time.
Fantastic.
And unit 3 is basically your electricity and magnetism. And you should be careful on this one. This is, I think, the most difficult out of all this electricity and magnetism. And unit 4 is relativity. Unit 4 is relativity. So these are the 4 units that we'll cover in this course. First is classical mechanics. Second is basically this is also called thermal physics. And third one is the electricity and magnetism. And fourth one is the relativity. Okay. Sorry, I also forgot to introduce myself. So my name is Tanmoy Ghosh. My name is Tanmoy Ghosh. Okay. And if you have any, I think already all of you already know my email ID. But still, if you have any doubt, you can reach at this email ID. Okay. This is tghosh@rgipt.ac.in. I'll be your course instructor for this classical physics course. Okay. So today, what we'll do, we'll try to start with this classical mechanics part, and I know all of you read vectors in your class 12, and all of you also took JEE exam, so you guys are know vectors, what is vector and its properties. So I'll try to give some basic ideas about vector calculus. Okay, and this is you will also read during your mathematics course. I think that is called applied mathematics, or for you guys, or something real analysis, some. But there also you will read this vector calculus. Okay, so we'll start. We'll start with unit 1. Okay, we'll start with unit 1. And these are the recommended books. Okay, so these books, I know you guys are not in the campus, and so this is one challenge. Maybe you guys will face accessing this study material. So what I'll do, I'll send you the lecture videos every day, and also I'll send you this notes, that notes also. And this book you can follow these books. These books are available online also. Okay, so first book that I'll recommend, that is vector analysis. That is called vector analysis. This book is by Spiegel. This is a very famous book. If you search, you will get this book. This is Spiegel. And second book that will follow in this unit 1, that is electrodynamics. Electrodynamics. This is only the chapter 1. We'll come back to this book in unit 3, but for here you will follow only chapter 1. Okay, and this book is by Griffiths. This is second book, and these two books mainly will follow for vector analysis and your coordinate system. And the third book that will follow, that is the classical mechanics. Classical mechanics by Goldstein. Goldstein. And the fourth book that will follow, that is also called classical dynamics. That is by Greenwood. These two books will follow in end of this unit 1, when we'll discuss the classical mechanics like the Lagrangian or the Hamiltonian. So first initial 4 or 5 lecture will follow these two books, vector analysis and the electrodynamics book, only chapter 1, and these two books are for later part of this unit 1. Okay, So if you have any doubt regarding this course structure, you can ask me now if you have any doubts at this point. You guys can unmute and ask me at this point any question about this.
Sir,
Yes.
we have to purchase these books.
These books, if you search online, you will get PDF copies. These are easily available. Okay.
Okay, sir.
If you search, you'll get this book.
Okay, sir. Thanks.
Okay. I think I'm disconnected again. Any other question regarding this grading and the course structure?
Sir, can we buy this book?
Yes, if you want, you can buy yourself.
Sir, these 4 units for first year only.
4 unit only for your semester 1. Semester 2 will have modern physics. They have another 4 units.
Okay, sir.
Listen. Okay, if not, let's start with this vector analysis. Basically, we call this vector calculus. Okay. So this is called vector calculus. You will read this in your mathematics course as well. Okay. So I think you guys, okay, another thing, you guys switch on your video so that I can see. Okay. All of you guys should switch on. Okay. Your video. All of you guys have video facility. Can you guys speak?
Yes, sir.
Please, everyone, please switch on your video. See, if this class been offline, then it would have much more interactive. Okay. So now, if you guys switch off your video also, then I can see you. Okay. And it is something speaking on the platform. Neither you guys will enjoy, nor I will enjoy. Okay. See, if I can see all of you, that is much more interactive. Okay. So you guys should always switch on your video. If it is, I know in many cases maybe there will be trouble for your network. Not everyone has access to good networks, but so if possible, everyone have to switch off your video. Okay. And okay, so let's start with this vector calculus. So I think all you guys know what is vector, right? So you guys already read difference between a scalar quantity and difference between scalar and the vector, right? In case of a scalar quantity, you only have values. You only have the magnitude of values. For example, if we ask you mass of a particle or mass of something, is a scalar quantity that don't have any direction. But in case of vector, you have both magnitude and the direction. For example, you can say a mass of a particle, that is a scalar quantity. It has only some values. Let's say mass this is equal to 1 kg or 2 kg or something. It don't have any direction. So that is called scalar quantity. And in case of vector quantity, you have both the direction and magnitude. Because let's say if somebody is moving at some speed, let's say 5 kilometer per hour, 5 kilometer per hour, it does not mean anything because we don't know the direction in which direction is moving. he or she moving. Maybe he or she is moving in a circular path or in a straight line, or we don't know. So we need to know in which direction he or she is moving. So in those cases, you need to have both the values and magnitude as well as the direction. That is called vectors. And you know vectors, how to represent the vectors. So basically, let's say if, position of a particle, let's say you have a coordinate system x, y, z. Let's say this is your coordinate system x, y, and z, and this is the position. This is the position of a particle p, x, y, z. And then you know how to represent the particle. Let's say this is the distance, this is the position vector, let's say r. So you know how to write a vector. This is basically I cap x plus j cap y plus k cap z. You know this when I write this hat or cap, this basically represent the unit vectors. When I write this arrow, this is the vector. Unit vectors is basically which has magnitude 1. Direction, but it has magnitude only 1. So here I cap means this is of magnitude 1 and this is pointing towards x direction. This is a vector quantity. This is the position of the particle. Now, if you then you how to do algebra with these vectors. For example, what happens at two vectors a plus b, or if you do dot product two vectors a dot b, or if you do cross product a b, to do all this you know. Okay. So here what we'll do vector calculation, vector differentiation, and vector integration. So in your class 12, you already know how to do differentiation, right? So differentiation basically we do differentiation by calling dy dx, where y is the sum function of x. Y is some function of x, and then differentiation we call dy dx. And you also know how to calculate dy dx. So how do we calculate dy dx? So for dy dx, we take a very infinitesimal small change x. For example, let's have this is x and y, and we have some curve, and this curve is represented by equal to y of x. How do we do differentiation? Now we let's say we see what happens if we change x by x plus delta x, and then what is the delta y? So then delta y, this is basically, so we write change in delta y by delta x, basically y x plus delta x minus y of x divided by delta x. This is your delta y by delta x. Then we take derivative dy dx. This is all defined as limit delta x tends to 0. That when delta x very small, it tends to 0, and in that limit delta y by delta x, that is defined as a derivative of function y of x. And here we don't have any vector. This is basically a scalar quantity. Or any function of x, y, or z, we can define differentiation like that. This is called dy dx. Now, how do we define differentiation for a vector using and what method we should follow? So basically, what is the complication in defining the vector differentiation? That it has only the magnitude. In case of dy dx, this is a scalar quantity. Here we have only the magnitude. But in case of vector, we'll also have to consider the direction of the vector, because for vector we have both direction and the magnitude. So let's say we have some vector. Let's say we have some vector r, and it is a function of u. Let's say we have some vector. Let's say here this is some vector, and this vector is r of u. This is a function of u. So how do we define differentiation for r of u? Now this we can define delta. This will be the same the same definition delta RU by delta U. This is the R change in R when U changes by U plus delta U minus RU by DU. Now it looks the same. This formula and this formula both looks the same. But the difference is that here R of U is, let's say this is the vector. RU plus delta U, this is also a vector. And it not necessarily have to be in the same direction of R of U. Let's say this is R of U and R of U plus delta U can be a different vector in different direction. This can be your RU plus delta U. So your delta, what is delta RU then? This is your delta R of U. So in case of scalar, it has only the magnitude. But here in vectors, we have both the direction and the magnitude. So your R of U and the differentiation both don't need to be have the same direction. So it can be in different direction also. So and the rest of the formula is same. So we can call dr du. This is same as limit delta U tends to 0, delta R of U divided by delta U. Okay, so only thing that you have to be careful that these vectors R of U and these vector, they might have different directions. They don't need to have the same direction on parallel or perpendicular something. They can be in any directions. Okay. Okay, so and this is as a function of U. Now we also know that R, we can write R in Cartesian coordinate at I cap Rx, that is the x component of R, plus jy component of R, plus k cap z component of R. Now if we want to differentiate this vector, how will we do differentiation? So we'll do differentiation for each of this x, y and z component. So we can define then dr by du. This will be basically I cap drx dx plus j cap dry by dy plus k cap drz by dz. So for example, let's say we have one vector. Okay, so here you should be careful that U is a variable. Okay, U is not the component of the vector. U is a variable, but Rx, Ry and Rz, these are the component of the vector along x, y and z direction. So let's say we have some vector R of t. Let's say one particle is moving along some path and it is changing its position with time. And these vectors, let's say this formula is given by something like I cap 2t square plus j cap 3t minus 2 plus k cap 3t square minus 1. So now here you can see this U is basically t, right? And this component, this is the Rx component, this is the Ry component, and this is the Rz component. Now if we want to do differentiation, how does it look like? So dr by dt, dr by this is the position, then basically velocity of the particle. So we can also call this is velocity of the particle. So this you can do differentiation. So dr by dt, drx by dt, this is basically I cap 4t plus this is basically j cap 3 plus this will be k cap 60, right? So this is vector and this is as a time. You might encounter composite vectors. Right? Composite vector means, let's say you want to do differentiation for something like this, d of r. Phi is a scalar quantity and r is vector quantity. These are called composite vectors, right? So here your formula will be dr du plus d phi du R. This is one type of composite vector. You can also consider some situation like du R1 dot product of two vectors R1 and R2. Here what we can do, you will first do the differentiation of dr2 du, and then you do the differentiation of component dr1 du dot r2. Okay. Similarly, you also define cross product also du of r1 cross r2. You can have the similar formula. R1 has to do differentiation of dr2 r1 cross dr2 by du plus dr1 du cross r1. Okay, so these are natural. You can see this formula follows the pattern. Okay, if you have two components, first do the derivative of first component, and then you add the derivative of the second component. Okay. Also, here we have the differentiation with respect to one dependent variable. We consider R is a function of. We consider R is function of R of U only, right? So it is possible that these are dependent on multiple vectors, right? So it is possible that R is a function of, let's say, three variable U1, U2, U3. So how will do differentiation in that case? So there you have to do partial differentiation. That differentiation of this vector dr, this is basically del r del u1 du1 plus del r del u2 du2 plus del r del u3 du3. So you have, then if you have three or more, two or more variables, then you have to do the partial with respect to on all the independent variables. Okay. Now, if is the geometrical interpretation. If we know dy dx is basically the slope of a curve, right? For example, if you have some function, let's say like this is the x coordinate, this is the y coordinate, and this represent, let's say, y equal to f of x. And what is dy dx? So dy dx, let's say here, dy dx is the slope, right? This represent the slope of the curve, right? In case of a dy dx. So here also, in case of vector also, this is the same. So let's say we have the coordinate system x, again x, y, and z, and there is some curve, let's say like this, and this curve is governed by this vector r of u. R of u means, let's say, r of t. That there is some particle p at this position, let's say at this position p, and this particle is changing its position with time. So it will draw some curve. Let's say one particle is moving along a straight line. So that is the straight line curve. So here we consider, let's say, this kind of curve. This, as time changes, this particle follows this curve. Then dr du is also basically tangent. This is called tangent vector. This is the tangent vector. Tangent is, let's say, tangent, right? So here also this is a slope, and we call this is a tangent vector t. Okay. Now we know for every vectors there should be associated with a unit vector also. So if someone, let's call this tangent vector, how you calculate vector for this case? Okay. So this is r of u. This has x, y, and z component. Okay. So you can write this r. This is I cap d of rx plus j cap d ry plus k cap d rz. We are differentiating x, y, and z components. And then we we define one parameter which is called arc length, and that is defined
Excuse me,
as
sir.
ds square. Yes.
Sir, can you repeat the part explaining the partial derivative if the vector is in described with three variables using three variables?
This one.
Yes, sir. Yes, sir. Yes,
Okay,
sir.
so here what I told you that this vector is a function of three variables, u1, u2, and u3. So what we did earlier, if it is a variable of only one quantity r of u, we simply write dr du. Where is that? This is simply dr du. In this case of you have multiple vectors, then you have to follow partial derivative. Okay. So what we are doing that the function of dr, this partial derivative of dr with respect to u1, and we multiply du1, and then this is the first independent variable, and then we do the same thing with the independent variable 2, and we do the same thing with third independent variable u3. Okay, this you can derive yourself, but I think this derivation you will learn more in your mathematics class. Okay.
Sir, can you give example on that?
Yes. We'll give one example. Okay. We'll give one example we'll give one example. Okay, but let's do this one. This is called R, and this is ds square. This is defined as dr dot dr. Okay, and so what this is the arc length. Okay, and what is dr dot dr? From this formula you can write ds square. This is basically square of all these components, right? Dx rx square plus dry square plus drz square. So now this is we have not mentioned the independent variable here. This is only the change in arc length. Okay. Now if r is a function of u, then we can also write ds. This is the du. This we can write dr dot du dr dot du. You don't need to do this derivation. Okay, I'm just showing here. You just need to remember this final formula, because you will learn more on this in your mathematics class. Okay, you don't need to follow this derivation. We will not ask you, okay, you derive this arc length or anything. Okay, so then your arc length will be the integration of from u1 to u2 square root of dr dot du dr dot du and du. Okay. So why we are defining this? Because arc length is the measure of distance between 2 points on a curve. Like if it is a straight line, you can directly subtract between the first point and the end point. But if you have a curve that is represented by a vector, how will measure the length between 2 points? This is the arc length. This is the measure of distance between 2 points, and this we need to define the tangent vector, and that's why we are doing all this. Okay, so this is the arc length. So now what I told you that this dr du, this is the tangent vector along this direction, and I am telling you this s is the arc length of the vector. Okay, so how we'll define the unit tangent then? Unit vector or tangent, let's say this is called t cap. This is basically dr by ds. Dr by ds is the unit tangent, because we are dr du is the tangent along a particular direction at the point p, and s is the arc length. So if you divide the vector by its length, this is the definition of a unit vector, right? So this is called unit vector for this tangent. Okay, and you can also from there you can define this curvature. People also call curvature if someone gives you a curve and ask you to find out the curvature of that. This is called curvature, people, and this is the magnitude of this d t cap ds. And people also sometimes define radius of curvature. That is, I think, more familiar. Radius of curvature. That is defined as rho 1 by k. So we will not ask you to derive any of this. You just have some feeling for how this vector differentiation work and what is the physical meaning and how to define the unit vector and what its mean differentiation of a vector. Okay. So this way you can define the slope of a curve using vector, and you can calculate the unit vector for the tangent also. Okay. Now one more thing will cover today. Let's say called surface normal. Okay. Surface normal. What is surface normal? Surface normal is basically unit vector perpendicular to a surface. Okay. Unit vector perpendicular to a surface. So what is a surface? You know, let's say if you all of you are sitting in a room. Okay. So each of the wall, that is a surface, right? For example, let's say this is a cube. This is the room you are currently sitting in. Okay. So each of this wall, let's say this wall is a surface. Okay. This top side, this is also a surface. Now, how we define a surface? Now, let's say we attach one coordinate system. This is x, this is y, and this direction is z direction. So, how do we define surface? So, what is the formula for this surface? What we can say for this is along y direction? How we can define this surface? Let's say if I call something, let's y equal to 5. What is y equal to 5? Y equal to 5.
5j cap.
No, y equal to 5 is something constant, and for surface you have something like those constants. Constant of this independent variable, then you will get the surface. Similarly, this top surface also you can define one constant for your independent variable. So, and normal to the, what is the normal to the surface? So let's say this is the surface, this surface along y direction, and normal to the surface means some vector pointing along the y direction, either positive y direction or the negative y direction. Both are normal to the surface. For the top surface, some vector pointing towards the up direction or the down direction. Those are the normal to the surface. So how using vector differentiation we can calculate those surface normal? Using vector formula or using algebra, you can easily do that. How to define a normal, okay, to a surface. So instead of this cube, we can define a generalized surface. Okay. So let's say this is your x, this is your x, this is your y, and this is your z coordinate. And let's say there's some surface like this. Okay. There's some surface like this. Okay. And there's one point P on the surface. Let's say this is the point. Let's say this is the point P on this surface. And the vector, what is the vector? This is the vector R. Okay. Now for a surface, for a line, if you want to draw a line, you need only one independent variable, right? Like I wrote y equal to 5. But for a surface, you need two independent variables. Then only you can have a surface, right? So here, let's say R, that is a function of two variables, U and V. Okay. Now what is del R by del U? This is a differentiation, and this I told you, this is a normal. This is a tangent vector to the line or the curvature. So let's say this is one line and del R, del U, that represents a tangent to the line. Okay, let's say this is along this direction. This is one line that is tangent. This is one tangent vector which follows, which is tangent to this R of U, this line. And we can also define del R, del V, that is also a tangent vector for this curve, which is represented by independent variable V. So both del R, del U and del R, del V, both are tangent vector to the surface. Let's say this is some other direction. Let's say this is del R, del U, this is del R, del V. So both are tangent to the surface. And if we do a cross product of two vectors is a vector which is perpendicular to both the vector, right? So what is del R by del U? This is basically cross product, and cross product of a vector we know that is perpendicular to both the vector. So let's say we have one surface and one del R del U is tangent along one direction and del R del V is tangent along another direction, and the cross product of those two is a vector which is then perpendicular to the surface, right? And this is called surface normal. Okay, so this is called surface normal. This is called surface normal, del R del U cross del R del V. Okay, we can okay, so we'll end this lecture today here, and some of you asked for this multiple variable vector. We'll discuss that today, next day. Okay, and we can end with one example also, that let's say we have a curve. We have a curve R. Let's say this is given by t square plus 1 I cap plus 4t minus 3 j cap plus 2t square minus 6t k cap. And we want to find the unit tangent. Find unit tangent. So how you can try to solve this. How we find unit tangent to this vector. Okay. This you can do as a home assignment. How to solve, how to find the unit tangent for this vector. Okay. So in the next lecture, what I'll do, I know maybe some of you are still missing. So we'll little bit revise this lecture again, and you guys should follow this to try to solve how to find this tangent vector for this curve. Okay, and I'll send you this video and the lecture notes also. Okay. Any of you have any question at this point
Sir, that
regarding
example
class or anything? Yes.
sir, that example of partial derivative.
Yes, we'll cover next day. Partial derivative with respect to multiple variable, right?
Yes,
We'll
sir.
cover.
Okay.
You can imagine, I told you that one is a function of time. Instead of one time, let's say there is also temperature. You can imagine a vector, right? Let's say in this room there is a heat source, okay, and you want to measure the temperature at some distance with changing the time and the distance. That will be a vector depending on your temperature as well as the position. So that will be vector with respect to multiple variable. But we will try to cover next day again, okay? And that will also, that way we also define our next point, that is the gradient. Okay, we'll come back to this point. Okay.
Okay, sir.
Any other question on this one?
Sir, then we will get notes.
Notes, I'll send you the notes. Okay, I'll send you both notes and the link for this lecture. Okay. Any other question? I know this is so one thing is that this course will move very fast, okay? Because this semester is 4-month semester, okay? So, and this is online at this point. So you are having 4 lectures every week. So by the time you will come here, maybe your unit 1 will be finished, unit 1 and some section of unit 2 also. So immediately after you come, maybe you have to sit for midterm exam. So you guys should start follow the lectures every day. Okay, whatever we are teaching, you should try to follow. Otherwise you will lag, and then at the end you will have trouble for completing the course. Okay.
So
Anything
if I
else?
am not confident in some topic like vector differentiation, should I read that book,
If,
vector analysis?
no, these courses are mandatory. You have to do this course. You should learn differentiation in mathematics. That is prerequisite. You have already learned in your class 12 course, right? Differentiation. If not, you should learn differentiation. These are mandatory courses. You cannot skip.
Sir,
So
once
is
explain
vector
today's
algebra?
class.
Sorry, speak only one.
Sir, could you please explain today's class briefly?
I'll revise tomorrow again. Next day I will revise again. Okay.
Okay.
Okay. So let's end this class today here. Okay. Okay, guys. Thank you, and see you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Recording stopped.